Welcome to Learn Yourself. Today we are going to learn about properties of ethanoic acid, and under this category we are going to learn esterification reaction and saponification reaction. So our first reaction is esterification reaction, in which we are going to prepare the esters through this reaction. So in this reaction, when acid will react with alcohol, it will give us esters. Esters are a specific compound in which in middle of the two alkyl group, the COO group will be there, and that's why they are identified as esters. They are sweet smelling compounds and that is their identity. So here when we are taking acid and alcohol, let us understand the nomenclature of this acid. This has a carboxylic acid group, that's COOH. So that is carboxylic acid group. In this compound there are two carbon atoms. That means it belongs to ethane. So when ethane is there along with carboxylic acid, so oic acid will be the suffix for that. So it is ethanoic acid. So name of this compound is ethanoic acid. So this ethanoic acid is combined with alcohol. Now here the substitute group is OH. OH is alcohol and it is along with the molecule which has two carbon atoms into that. So again ethane is there and it is combining with alcohol, so it is OL. So OL will come as suffix. So ethane and OL, so this compound is ethanol. That is how we are going to write the nomenclature for this compound. If you have any doubt regarding the nomenclature, please refer my video based on nomenclature of organic compounds. Now when ethanoic acid and ethanol will react, it will give us esters. Now let us understand how esters are formed from these two compounds. So when ethanol and ethanoic acid, that means alcohol and carboxylic acids, will react in presence of acid, the H will get removed from the alcohol and OH will get removed from acid compound. So OH and H will removed as a water molecule and remaining compound will join as something like this, that CH3, CH2 and remaining oxygen will be here. Along with that, this CO group will join. Along with this oxygen, this CO group will join. And as we know that the structure of carboxylic acid is something like this, that COOH, structurally if you want to write, it is carbon is joined with oxygen with double bond and it is joined with OH with single bond. So here you can see that carbon's 3 valency have already been satisfied. Now it is lacking with only 1 valency. So here I have written that carbon which is attached with oxygen, that is double bonded to the carbon, and after that the CH3 will be there. So now carbon's 4 valency have been satisfied, oxygen's 2 valency have been satisfied, and now this is our ester. And the IUPAC name of this ester is ethyl ethanoate. So here esters are a product of acid and alcohol and they are giving us esters. As this substance are sweet smelling substance, they are used in perfume as flavoring agents. Now let us understand the saponification reaction, in which these esters we are treating with the base, and as a result we will get some of the compounds which we are using in manufacturing of soap. Now this second reaction is referred as saponification reaction, whereas we have taken here esters. This is the same molecule as this CH3 group is there along with COO, that is this group, and CH2 CH3 we have combinedly wrote as C2H5. Otherwise this esters and this ester, both are same, they both are ethyl ethanoate. So when this ester will react with base, that is sodium hydroxide, it will give us alcohol back, that is what is earlier thing, that is ethanol. This is also ethanol and we can also write this structure as CH3 CH2OH. This both are same, only thing that we have combined this as C2H5OH, and here we have written it separately. So this is the same thing, that when esters we are treating it with alkali, we will get our alcohol back, and along with that we will not get ethanoic acid, but we will get sodium salt of carboxylic acid. So this is carboxylic acid and this is a sodium salt. So sodium salt of carboxylic acid we will get, and this compound is important for soap manufacturing process, because into the soap we required a long chain fatty acid of carbohydrate, because soaps are long chain compounds of carboxylic acid, something like this, and one end of that will always have sodium or potassium. That means they are salt of sodium and potassium, and along with that long chain carboxylic acid will be there. So now these two reactions are completely different reaction. The first reaction is esterification reaction and second reaction is saponification reaction. Now let us see what is the difference between these two. That first reaction is happening in presence of acid, whereas saponification reaction is happening in presence of base. This reaction requires heat to proceed further. This reaction do not require any kind of heat. From the first reaction we will get esters as a product. From the saponification reaction we will get sodium salt of carboxylic acid and alcohol. So these are some of the basic difference between esterification reaction and saponification reaction. Our third property of ethanoic acid is reaction with base. So when ethanoic acid is reacting with base, it will give a salt. Same way how acids are reacting with base, same way this carboxylic acid will also react with base and it will give us salt. But here we are going to get sodium ethanoate, or it is known as sodium acetate, because here this is CH3COOH is acetic acid group. So this molecule is known as acetic acid, in which one carbon is there and one COOH group is there. This is carboxylic acid and it is attached with methyl group. So this is known as acetic acid. It is also known as ethanoic acid because there are two carbon compound. Acetic acid is its general name. So here, as per IUPAC name, this is ethanoic acid and its general name is acetic acid. Whereas here what we are getting is, instead of H, we are getting here Na. So that's why it is known as sodium ethanoate or sodium acetate. Whereas this COO is represented as OH group, so that's why it is named as sodium ethanoate, and it belongs to acetic acid, so that's why it is named as sodium acetate. From these two compounds the water molecule will be removed and as a result we will get sodium ethanoate or sodium acetate. Now our third reaction, in which ethanoic acid is reacting with carbonate and hydrogen carbonate. Our fourth reaction of ethanoic acid is with sodium carbonate and sodium hydrogen carbonate. So in this, from these two different reaction, where here sodium carbonate is there and here we will get sodium hydrogen carbonate. So the difference is only that here we are going to get two molecules and here we are going to get only one molecule. Otherwise the product will remain same, that we will get here sodium acetate, water and carbon dioxide. So as a reaction product of ethanoic acid with sodium carbonate and sodium hydrogen carbonate will remain same, that sodium acetate, water and carbon dioxide. But because of the hydrogen, which is more here compared to here, so the balancing of equation will be different, as here we need to take two molecules and as a result we will get here two molecules of sodium acetate. Now let us see what is the basic difference between esterification reaction and saponification reaction. So in this reaction, when acid will react with alcohol, we will get esters. This reaction is producing esters, and that's why it is known as esterification reaction. Let us understand this. Here CH3COOH is there, C2H5OH is there. So ethanol is reacting with ethanoic acid, and in presence of acid and heat it will give us ester and water molecule. Now what is there in saponification reaction? So in this, esters will react with base. It will give us sodium salt of carboxylic acid. This compound is used in manufacturing of the soap, and that's why this reaction is known as saponification reaction. So the reaction which give us a molecule which we can use it in manufacturing of soap. That's why it is known as saponification reaction. This esters which we got it from esterification reaction, that will react with base, that is alkali, sodium hydroxide, and it will give us sodium acetate, and that alcohol we will get it back. So sodium acetate or the sodium salt of acetic acid we will get along with the alcohol what we have used in esterification reaction. That produces compound which used in preparation of soap. That's why it is known as saponification reaction. Now what is the other difference in between these two? That it happens in presence of acid and heat. Heat is required in this reaction, whereas this reaction happens in presence of base. So both of these reactions are very easy when you will learn it simultaneously. That first we are producing esters, that esters will react with base, we will get sodium salt, and along with that we will get our alcohol back. So hope this video has cleared your doubt. In coming segment we are going to discuss many more important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.